So for our topic, we are going to figure out a group of students is decided to make an experiment to find the property of ice and water. They find out the rate of absorbed heat for the ice and water is equal to x power 3 and exponential 3 minus 2x. So our first problem is the changing state of water in terms of time, which means the x coordinate and y coordinate intersect. For the second problem is the time whether the ice and water experience exothermic and endothermic, which is exothermic is mean increasing function and endothermic is decreasing function. And the third part is finding the point of inflection. And the fourth part is the open interval of concavity for the rate of absorbed heat. And the fifth part is the time where the water is at boiling point, which is local maxima or minima, whether the function is maxima or minima. And the final part is sketching the graph in terms of this function.
For the first part, we want to find the changing state of the water in terms of time. Therefore, we need to find the x-intercept and y-intercept. To find the x-intercept, we need to assume that y equal to 0 and then the sq will equal to 0, s will equal to 0. Now we will find the y-intercept, which is s equal to 0 and we need to substitute s equal to 0. Therefore, y will be equal to 0. And next, we will say that the ice will melt at the 0, 0. Next, for the part 2 is the time when the ice and water experience exothermic and endothermic, which means exothermic is increasing and endothermic is decreasing. We will find the difference of s and then you will get the s squared e3 minus 3s and times 3 minus 2s for the exothermic, which is increasing function for s is bigger than 0. Therefore, the solid equation will be like this. The 3 minus 2s is bigger than 0 and we get the s is smaller than 3 over 2. That means the smaller than of 3 over 2 is increasing function and the bigger than 3 over 2 is decreasing function. We can get that for the increasing will be lesser than the, we will get the interval which minus infinity to 3 over 2 is the increasing function and 3 over 2 to infinity is the decreasing function.
We want to find the point of inflection, so we find the second derivative and third derivative. So the second derivative is for the test for find the local maximum and minimum. So we continue to the third derivative. So the third definition is for double check for the point of inflection of x coordinate.
So for the point of inflection, we let the second derivation equal to 0. This because it's always positive, so we no need to analyze it. Then we find the x value. Then we figure out that the x value is 3 plus square root 3 over 2, and the second one is 3 minus square root 3 over 2. And the one more is this is always positive, so we no need to analyze. So here we got the 1x, which 2x equal to 0, x equal to 0. So for finding the point of inflection, we let the second derivation equal to 0. Then we got this equal to 0, this equation equal to 0. Then the exponential function is always positive 1, so we no need to analyze. So here we got the one root from the 2x, which x equal to 0. And we analyze this equation, which is, then we get the x equal to 3 plus square root 3 over 2, and another one is 3 minus square root 3 over 2. So the point of inflection of x coordinate is x equal to 0, 3 plus square root 3 over 2, 3 minus square root 3 over 2. So we need to double check whether this point is point of inflection or not. So we conduct the third differentiation, which is not equal to 0. We substitute the x value into the equation. Then we get the 0. Then for the 3 minus 3 over 2, we also get the answer equal to 0. And we need to double confirm it. So we conduct the third derivation. We substitute the value into the third differentiation. So calculate it. Which the equation is at here. We calculate, substitute 0 inside here. You have here. Inside here, inside here. Substitute x equal to 0 inside here. So we get the figure is 120.51. Then we test this x coordinate. Also the same. Substitute into the third derivation. So we get a negative value, 24.83. And there's one more for the 3 minus square root 3 over 2. Okay, it is 2.90. So That means the point of inflection for x coordinate is x equal to 0, 3 plus square root 3 over 2 and 3 minus square root 3 over 2. We are going to find the open interval of concavity for the rate of absorption of the heat. So we just put the interval where negative infinity to 0, 0 to 3 negative square root 3 over 2, 3 negative square root 3 over 2, 2, 3 plus square root 3 over 2, and final one is 3 plus square root 3 over 2 to the positive infinity. Then here is sample, here is second duration. We're gonna to test the concavity, and we simply put a sample which is in between negative infinity to 0. So I put negative 1. So we are going to find the figure. Which is equal to negative 22, which is lesser than 0. That means it is concave downward. And for the interval 0 to negative 3 minus square root 3 over 2, we simply put one number which is 0.5, and we substitute into the f prime x here. And we get the 0.5, which is larger than 0. That means it is concave outward. And for this, we put the sample is equal to 1. And we substitute into the f prime here. And we get the negative value, which is lesser than 0. That means it is concave downward. For this interval, we put 3 and figure out the f prime value is what? So we get this is 18, which is positive value and bigger than 0. So it is concave outward. Therefore, the function is concave upward here and here, which is 0 to 3 negative square root 3 over 2 units, 3 plus square root 3 to infinity. And it is concave downward from negative infinity to the 0, and here 3 minus 3, 3 2, and 3 plus 2.
Going to find the time where the water is at the boiling point or a local maximum. So first, from the first derivative, which is equal to 0, so we only take these two, we consider these two because this is always positive. So x2 is equal to 0, 2. So from this, we use the first function, take equal to 0, this will be equal to 27. So the point is 0, 0 and 2. The coordinate for 0, 0 is a stationary point. I mean it's a inflection point. I'm sorry. So we just have to analyze for the this part for 3 over 2. So from 3 over 2, we use the second derivative, which is 3 over 2 equal to negative 9 over 2. So negative 9 over 2 is less than 0, so it is a local maximum. For the last part, we are going to sketch the graph of temperature against time. So temperature is y-axis, time is z-axis. So we have this is 27 over 8. This is a boiling point. This is the time. So from ice, it goes to 0, 0. This is an inflection point. So it goes to the boiling point. This is the boiling point that we find before. So as we know that if water, we usually after it's consider the boiling point, it was always goes low.